Okay, I wanted to show one more example with graphing inverse functions. So another way you could do this is by making a table. So maybe you don't like algebraically finding the inverse function by flipping the x and y, solving for y, and there's your inverse, and then graphing that. Another method that you could do is using a table. So for example, let's just go ahead and graph our original function, 3x minus 2. And so I'm going to start down 2, put a point here. My direction to go for my other points is going to be to go up 3, right 1. So up 3, right 1, up 3, right 1, and so on. And then when I run out of room, I can go down 3, left 1. So down 3, left 1, down 3, left 1, and so on. So here is that line here. And again, arrows going in both directions. So this is what this looks like. So we have an idea of what the inverse should look like, right? This should fold over and land, and this should fold over and land. But let's go ahead and see how we can do this without going through the process of finding the inverse algebraically. And let's take a look at how we can find this on the table. A couple ways to think about this. F inverse of x, the table here, f of x, we already know some of these points. So for example, when x is negative 2, so when x is negative 2, what is my y value? Well, it's way down here at negative 8. So this should be negative 8. Now, if you don't want to actually use your graph to find those, you can plug it in. So 3 times this negative 2 is going to give me a negative 6. At negative 6, taking away another 2 is negative 8. Now, when x is 0, if you look at your graph, when x is 0, y is negative 2. Or when x is 0, 3 times 0 is 0, minus 2 is negative 2. However you decide is fine. When we plug in 3, 3 times 3 is 9. 9 minus 2 is 7. So when x is 3, y is 7. When x is 4, 3 times 4 is 12. And then 12 minus 2 is 10. And again, that's what we see here. When x is 4, y is 10. So it doesn't matter if you want to use the graph that you already put on the coordinate plane and look at those points, or if you want to plug in your values for x here. Okay, why did we make this table? What was the point of doing that? Because now when you go and make another table of x inverse of x, what's going to happen is to find the table of your inverse, all you have to do is flip x and y. So remember how that was one of our steps when finding the inverse of a function. We would say y equals 3x minus 2, and our first step was to flip x and y. So that's all you have to do on a table. So if my coordinate point for my original function was negative 2 comma negative 8, my coordinate point of its inverse is going to be that same thing flipped. So in this case, that'd be negative 8 comma negative 2. Instead of 0, negative 2, it's going to be negative 2, 0. Instead of 3, 7, it's going to be 7, 3. And instead of 4, 10, it's going to be 10, 4, good buddy. So now I can take these points, not even having to solve this for its inverse. I now know 4 coordinate points for the inverse function, and if I plot those and connect them with a line, that should be my inverse function. So let's see if that works out. So negative 8 comma negative 2. That means I'm going to go left 8 and down 2. Negative 2, 0. I'm going to go left 2. I'm not going to go up or down any because it's 0. 7, 3. So I'm going to go right 7. 1, 2, 3, 4, 5, 6, 7. And then up 3. 1, 2, 3. And then finally 10 comma 4. So I'm going to go right 10 and up 4. 1, 2, 3, 4. And so if I were able to have the largest straight edge in the history of mankind, I could connect these with a straight line. And if I do that the best I can here, we see that these should reflect over this line y equals x. So there is a way, just using a table, to take your original function, not going through the algebra of solving for the inverse and graphing from there, but you can take that table, flip your x and y values, and graph from the table.